Okay, historically, data center development in Europe has been concentrated in major metropolitan hubs. I guess FLAP-D is what everyone knows about. But what's driving the shift toward I don't know whether you call them tier two or if that's the official expression, the sort of slightly smaller or lesser locations, but tier two locations. What's driving that shift today?
Yes, Phil. So I would say, especially from a Vertus perspective, when we started to look into expansions and also looking what the trend is, what the market is saying, what our customers are wanting to is, I mean, let's not kid ourselves. Tier one market, FLAP-D, they continue to be, the focus, the focus of growth. However, they're getting very, very congested, right? And also, if we look at the technology that our customers are looking to implement, also going to, the entire AI workload. So we are struggling, the industry is struggling to find the right amount of power, the big plots of land, and all of that to be able to build big campus in the tier one market. So that's why we've been starting to look, more and more into alternatives. And tier two markets, as we call them today, they're still close enough, right? They are well connected through the fiber, etc., to the tier one markets. Some of these are new regions. Our others are markets within the same countries, and we are seeing that. So, in a nutshell, they're close enough, right? But are giving the ability to build large campuses, for scale, focus on efficiency, sustainability, etc., and very, very important, has that access to power and to loads of power, right? We're not looking to get the next 5 megawatts within the market. We're trying to think in blocks of 50, 100 megawatts.
Okay, and in terms of the planning sort of horizons, is that a key difference? I mean, one hears stories of certain, or certainly I think Amsterdam people always quote as, difficult to get planning permission. I don't know whether that's the case in other flat D areas, but how does that contrast maybe with tier two locations in terms of allowing operators to plan for sort of sustained growth as opposed to just sort of a little bit of immediate capacity?
Yeah. So there are similarities, of course, as well, but let's say markets that are not as congested yet, that are newer to the data center world. If and if we as providers in the data center industry do it in the right way, that we start from the beginning by educating, the authorities, by bringing the people along the journey, it is seen that these difficulties are not there, from the start. It's really up for us. We're able to kind of influence that planning trend. So to give you an live example from we are building right outside Berlin and Brandenburg, and we're building a 300 megawatt campus. Before we bought the land, before we put the ink on the paper and all that, we approached the authorities, multiple different authorities, so the municipality itself. We talked to the state authorities. We brought politicians along the journey, educated them on what are we trying to build, who are we. Yes, we are a foreign company. We're going to bring, direct investment into the area of Brandenburg, and it is now coming to an point that we are very successfully able to, in a fast track, also a lot of the planning, not only from building a data center, also from a power perspective, right? So it goes into all areas. I can't say it's the same everywhere, right? There will be also other areas that are a little bit more difficult, but I think it does allow us that chance to start fresh from the beginning.
Again, well, you've referenced power a couple of times. I guess it's no secret that power is the sort of the number one sort of focus for pretty much everyone looking at building data centers with land, I guess, also important. But power infrastructure, so for long-term operations, how do the tier two locations, do they make it particularly easier to design sort of scalable, stable, and adaptable electrical systems, or just, the whole sort of power supply chain?
Yeah, so I would say one thing that is very special about many of these tier two locations, and especially by picking these locations, that you have more access to to a large voltage, right? So you're not trying to get, like in the metros, from an urban substation, a 33 kV connection. You can actually go really on a 380 kV connection all the way up to or something like so. So there are different ways on how you can look at obtaining that power, right? That opens up also possibilities of which are also new to us, right? There are not that many data centers that have been built in that so it's also been learning by doing, but working very, very closely with the different power providers, and I think that is the key difference, right? Of course, you'll have one or two projects maybe in metros that you can also go into that direction, but you're seeing those bigger connection, more and more in tier two markets.
Okay, and AI and high performance computing workloads, obviously that's what everyone's focusing on at the moment
Yeah.
for data centers. And uh, excuse me, how do the tier two sites support these workloads more effectively? I mean, so is AI practical, I suppose, maybe in tier ones, and if not, or if it is, but why would tier two sites be more effective perhaps than tier one urban sites?
I mean, absolutely. AI APC is also, of course, possible in tier one, right? I mean, if I were the customer, I want to have everything, close to my original clusters, right? So I would say it is not that it's only possible in tier two markets or in tier one markets. However, one thing that we are seeing is AI, they produce continuous high density thermal electrical demand, right? So therefore that is giving us pushing more and more to larger campuses, where we can have that flexibility of how do we deal with that addition, like with the high, we need a lot of power, there's going to be a lot of heat coming out of that, and therefore it's better if it's rural, if you have large campuses where you can build in a modular way, that also allows flexibility and design, right? So if we're looking at the cooling, right, is it going to be high density liquid, or is it going to be some hybrid cooling? It gives you more flexibility when you are in the large campus areas, and it is those large campuses are more and more coming into your two markets. It's of course, if you can find the right plot of land and that amount of power in tier one, absolutely it would be possible there as well, right? But from an engineering point of view, right, we want to find the right location for AI and HPC, where there's power blocks that are designed that can persistently offer the 60, 120 kilowatt racks clusters, that and that we are seeing more and more in tier two markets.
Okay, and just following up on the cooling side, is
Mm-hmm.
it simply a question of there's generally more space in a tier two location, so you've got the room to put the cooling in? Whereas again, I know perhaps people exaggerate, but they're talking about legacy data centers. If you put some AI in there, you'd perhaps have, three cabinets and the rest of the, data hall would be full with the cooling solution. That might be a bit of an exaggeration, but
Yeah.
just talk us through, I suppose, why tier twos are more amenable, should we say, to the cooling required for high density workloads.
Yeah, so I would say it's a combination of also it depends on the country again, and tier one markets where there's already a lot of congestion of data centers. There are We often see that there isn't a flexibility so much on certain designs. So for example, if you want to use water, there's a lot of it's not accepted as in many places. For example, also you have to, as you talked about, you have to work with very dense spaces, right? And building more up and then that. So I do think that those kind of things feed into what kind of cooling you can add. And again, it's tier two, going back to that point on building, being able to build modular, being built on bigger spaces, and that you can adapt your design accordingly. Yes, you can. If you build a campus, you can build also data centers for multi-purpose, right? And especially if you're going into areas that are not traditional, just for for the standard traditional cloud in the tier one market. However, you can build a campus where you can have 3, 4+ buildings, and then have also different cooling topologies within those buildings. You don't have to just go into one direction, which opens you also the flexibility and giving the customer the opportunity to also grow over time. Because I mean, let's face it, everybody's talking about AI, and we're seeing now how it's developing, but our customers themselves, they're also still trying to figure out how is all of this going to work. And if you put yourself, if you have one building and you have a design for specific design, you might not be able to give that flexibility in the future than if you go into campus structures.
Yeah, and I'm just wondering from an operational perspective, are there any particular advantages that tier two sites offer? I'm thinking things like system standardization, maintenance, testing, particularly as you mentioned, campuses will expand over multiple phases.
Absolutely. So I think that is one of the key operational advantages that you, of course, when you plan a campus, you have to do a master plan, right? So you need to decide what infrastructure and all of that according to a specific master plan. And ideally, you are building a modular campus, which yes, can be tweaked to customer specific customer demands, but to a certain extent, and the basis stays the same. But if you go from the moment that you enter the campus from a security point of view, and also operating then the individual buildings, there's going to be a standardization in operations, right? So therefore, it starts with the commissioning, right? And then over time, but also running that data center, you can you can have efficiency also by the staff that you have from the access perspective. And if from the first building from a commissioning point of view and also running it, and then you're building over a period of 3, 4, 5 years the campus out, it is business as usual as you're growing. So you're becoming more and more efficient, which of course then also goes not only on operational excellence, but it's also a cost saving, right? And I think if we look at what our customers looking at, it's not only the time to market. Of course, it still is. You need to be at the right time, at the right place, right? No questions asked. But it's also about how stable are you, how adaptable are you, and how much runway can you give, right? And that is from an engineering point of view, but also from an operational point of view, right? The more stable you are, the more that that's that operational excellence that is going to give that customer also a long-term commitment.
Yeah, and I guess connectivity remains critical, but it's perhaps no longer, the dominant constraint. And just be good to understand how improvements in fiber, and I know there's a lot of work laying subsea networks, cables at the moment. So how's that changed location decision process for data centers? What's it brought to the party?
So, I mean, the long haul fiber routes now, they're offering multiple diverse paths, can also go beyond metro regions. And before everybody would be concentrating, metros maybe plus minus 10 kilometers, and we are seeing more and more data center campuses, right? Going out 30 kilometers, 50 kilometers. I mean, there isn't a number that's like this is it, right? But we're going out more and more. And also would maybe a customer go further out for a 10 megawatt data center? Maybe, but unlikely. Would they go further out for a 100, 200 megawatts data center that allows them to grow there over time? that makes absolutely much more sense. And it is the the evolution in the connectivity that is allowing this now, right? So it's not some. I mean, fiber and connectivity is important, but it's not the one sole criteria anymore, right? So therefore, it's really about how do you triangulate or optimize, the power topology with also the long-term, scalability, and also being able to give that engineering innovation and flexibility.
And presumably tier two sites, they can also contribute to resilience because of the geographic diversification that they bring. Just your thoughts as to how spreading capacity across regional locations can help reduce operational and sort of systemic risk.
Yeah, absolutely. We're seeing that it's always been there, right? So I mean, our big customers as well as enterprise customers, and that's why you have disaster recovery sites, etc. You're trying to have a diversification of plots. I think that the tier one markets, if you look at them, that is why there is FLAP-D and not just one or two markets. It's the diversification. Yes, you have customers that want a specific country, a specific regulatory frame, but most of the workloads, talking about Europe, it's not because it needs to be in France or it needs to be in Germany or it needs to be in the UK. They want to be in Europe, but therefore they need to be diversified. And as we are also seeing now that, again, I'm using that word congestion so much, that it's difficult to grow, but the demand's still there. There's new workloads coming. So therefore, you need to see, okay, where, how can these be spread? And if there's one or two new tier two markets that are coming up, they are adding, they're not instead of, right? They're adding that growth that Europe is having in terms of cloud infrastructure, but also new technologies such as AI. So I mean, we're seeing what's happening in the world, right? There's diversification is important, but I wouldn't want to be focusing too much on the political end. It is, if we look at the straightforward thing, let's look at power. If the main grids, what happened in Spain, a couple of months ago when there was a big outage in Spain, that affected a lot of areas, right? And while the data center managed all to stay live, which is also shows the great engineering of our industry. Nevertheless, we're using much more power. We need to make sure that there is a diversification on the grid nodes that we're using. So it doesn't also only have to be different countries. It can also be different regions within a country, right? And having those connected. And so I think there's more and more as digitalization is becoming heavier and growing much more in the world. We need to be able to be more resilient by that diversification of the locations.
Okay, and then we come on to sustainability, and I guess there are other regulatory requirements that are becoming increasingly important for the industry. And I guess it's a slightly uncertain situation at the moment, but I guess everyone knows the direction of travel. How do you think that tier two locations can help operators plan for efficiency and potentially, compliance over the long term?
Yeah, so again, starting with grid connections, as we are going into expanding our beyond the tier one locations, looking at where are the grid connections with better renewable penetration, right? I think that is one way to look at it. Then of course there's the topic of heat reuse systems, right? So Germany, for example, has made it now a law. In EU, it's a directive, right? And I think it makes sense, right? And when we're looking at tier two locations and starting again from the beginning, it allows us to work closely with regulators to see what is really possible. there again, it's the opposite. A 5 megawatt data center, it's easier to to find an off-taker of the heat for 5 megawatts than to find an off-taker of 100 megawatts plus, right? And then again, also, it's a little bit contradicting. Probably in a more, within the city, it will probably be easier to, find an off-taker for heat reuse than in the middle of the countryside, right? Nevertheless, it is these conversations are starting, and there are possibilities to work together with the communities to find interesting solutions. And we're very still in the early stages. We're still trying to find the right technology for it. There's a lot of theories on how, but you are seeing a lot of engagement from multiple different parties to make these projects a success, because this is in everyone's interest, right? And then of course from a sustainability we have the regulatory instance. You have all of the reporting that is coming, but I don't think that is so different from a tier 1 to a tier 2. That is Europe, right, in general, and I think it is also in in our industry's interest to build and operate sustainable data centers. Now, when we have regulators putting directives or even laws into place, we continue to hope, and I think we have a lot of help with our associations to make sure that our industry is also being pulled into these discussions and negotiations, and that they're not just put upon us without really understanding how it works for data centers.
And just on the heat networks point of view, am I right in thinking, although people like the idea of having a data center here and almost next door a potential user of that waste heat, you can actually transfer heat reasonably long distances efficiently, so that perhaps opens up more use of waste heat. Is that right?
Yes, that is. So we're actually working on a project with, again, our data center campus in Wustermark, which currently, so we have 300 megawatts, incoming into that data center, and we're working together with the municipality of Wustermark, who has a great idea on how can we use that power. The municipality itself is not very big. They wouldn't be the biggest off taker, but they now went out and found a partner, which is the city of Potsdam, right, which is not so far away from Wustermark, who is building a completely new apartment buildings, innovation park, etc., at the northern borders of the city of Potsdam, and that is more than 10 kilometers route, and they are doing a pilot project. It's still it's still in the phase of exploration, but they're actually having multiple people, multiple different companies. They're investing the time and the effort to see if it can work to transport that heat that comes from our data center all the way down to the city of Potsdam. And then of course that there's that question of you have to maintain the heat at a certain level for it to be reusable. How that can be done? There's a lot of renewable energy, wind power plant around along that route. So the concept isn't done yet; it's in the making, but it is an absolute interesting project. And we as Vertis are involved in it because we would be giving our heat, but it is actually not Vertis who is doing this entire project. Is the municipality of Wustermark with the city of Potsdam putting their heads together and actually embracing such a big data center campus, saying like, we see this as a huge opportunity for us to make a very, very sustainable impact to the greater area of Brandenburg. And I think that is an excellent example on how we should be looking at data center developments and sustainability and use, and not just look at the negatives on, oh my god, how are we going to do this and is it going to work or not. And yeah, so I think that is that is a wonderful example. It's still going to take us a couple of years to figure this all out, but the initiative is there, right? And I think that's the important part.
Okay, couple more things. I mean, designing for operational continuity, potentially a major benefit for tier two development. Be good to understand how planning for multiple phases and consistent infrastructure can help reduce complexity and risk.
Yeah. So in the multi in many I won't say all, but in many tier two markets, you of course start with the master plan because you do need to have an environmental permit, right, that incorporates the entirety of the campus, right? And there's more and more attention to it. So therefore, you cannot just do building by building from a planning perspective. You do need to look at it from a as a whole, but that comes with a lot of advantages as well as said before. So if you once you get that environmental permit, and which is probably the most challenging one, right? Because it comes with the big numbers of
Mm.
emissions and all of that. But if you have that in place, then building modular permits that stay within that grand master plan. Let's put it that. Becomes more business as usual, right? If you do the first building permit, then planning towards the next buildings is not so much of a challenge, unless you really have to go back in there change because the technology has changed, which happens as well, right? But that's from a permitting point of view. Planning itself is you save a lot of time and also money if you do if you plan in a campus where you can, from an M&E perspective, you can purchase in bulk, right? You can do economies of scale in that. You can also make sure that if you know you're going to be building over the next 3 years, building after building, but then you have the long lead items and the kit already stored in hand. You don't have that risk of delivery anymore. Then also from a modular build perspective, there's a lot of more prefab as well that you can use. There's a lot of different ways on design and engineering that can help your speed to market, but from an efficient, but also cost efficiency, which ultimately is also one thing that that drives the entire campus ideology.
Yeah, and you mentioned speed to market there, and that potentially, I guess, was one of, if not the major measurement of success in terms of delivering data center projects. But I'm thinking that those sort of metrics are maybe evolving. So we've got things like longevity, adaptability, operational stability. So just your thoughts as to, how today one would measure the success of a project as opposed to just, we got it built in 6 months or a year, or which perhaps was once upon a time the sort of gold
Yeah.
standard.
I mean, you mentioned the keywords, right? So, it's I would say as AI and cloud, as they are evolving, there's that long-term stability that is needed. So what does that mean? It's we have to be able to have stable PUE profiles from an engineering point of view, adaptable cooling topologies, as I said, right? Especially from an AI in the longer term. The technology might say we want this cooling today, but maybe in 2 years' time there's a more efficient way, so we need to be able to change that again. And so therefore, this is what I mean with long-term stability for our customers. If they have that flexibility, that adaptability in a stable environment, which is a campus, you don't have to go out and find new space once you've grown up. You can come in, get your initial a few megawatts, and then grow there over time. And that has become a performance metrics for itself, I think. And of course, with that operational excellence, excellent. So you said it yourself. I mean, I think it's speed to market remains important, but speed to market gets you online. Speed to market for a data center provider, speed to market gets me the deal, right? For a customer, speed to market gets you up and running and online. But it is the longevity, the engineering longevity, it's the adaptability, the stability for that keep these sites, these data centers relevant, right, for the next hardware generations that are coming.
And maybe just finally, looking into the future, do you think that tier two locations, I mean, clearly they complement established hubs. Do you think there are any of them that might end up being sort of classified as primary growth markets for Europe's next generation data centers, or will they always sort of, continue to be secondary or tier two locations? Just your thoughts as to, how they might evolve.
I do think that there's going to be an involvement. I mean, we all, I mean, FlapD, everybody knows it and
Mhm.
talks about it now. But I mean, you already sometimes see it. Should an M be in there? Should a B be in there? So I do think it's going to change. They're not always going to be second tier. Tier two location, they will, I strongly believe that they're going to be the primary landing zones for high density and a long duration capacity. And with because in the metros, so the tier one, they need to start expanding more as well. But if we really stay within the current measurements, they won't have that ability to grow than tier two markets have. So will there be a moment when they take over? I wouldn't talk about that. I'm just going to think that they're going to have the same type of importance than tier one markets. They're going to be primary markets. They might have different end products, let's put it that way, right? But I do think that tier one and tier two markets still have going to continue growing next to each other, and there's not going to be a difference among them.
Yeah. And actually, just one final thought, promise. Just do you think there's beyond that? Because I mean, at the moment, everyone's obsessing with AI, the large language models,
Mm-hmm.
the huge sort of data crunching, but we clearly know the edge. Everyone talks about the edge and AI at the edge, inferencing, etc., seems to be, a big future as well. Do you think
Yeah.
we'll end up with sort of tier three and tier four locations over time, bringing, the AI closer to where it's actually being consumed?
Yeah, I do think that inference and of that is absolutely has a future in Europe, and that yes, as the same with Edge, right, with the cloud front, then they're going to be, or they should be in every major city, right? I think that is, but here we're not talking about the 100 megawatt
No, no.
campuses,
Yeah.
right? So it's more like the edge nodes. But absolutely, I mean, if this is not happening today, that is where the future should be going in order to be able to push through that digitalization, and for Europe also to be a competitive market in digitalization and in the AI world.
Excellent. Christina, as ever, it's been great to chat to you, and thank you so much for sharing so many brilliant insights
Thank you,
into what
Phil.
is going on. It's an exciting time for many reasons, so really appreciate your time today. Thank you.
Absolutely. Thank you very much, Phil.